For today's lesson, I have set you a test to do. Questions 1 to 8 use what we've been doing on Tuesday and Thursday with adding, subtracting, multiplying and dividing fractions. Question 9 onwards use the same methods, but they're a little bit different. You haven't seen these types of questions. So there's one type of question for question 9 to 12, and then there's another type of question for question 13 onwards. I am going to do 2 examples to help you with those questions. If you want to have a go at those questions first and then watch the video, that's fine. Or if you want to watch this video first and then have a go at the questions, that's fine too. So questions 9 to 12 are going to look a little bit like this one. It wants us to solve this subtraction of algebraic fractions, by which it means it wants us to find some values of x that make this true. So to solve this, we're going to use the methods that we've used for adding and subtracting algebraic fractions. The first thing I'm going to do is I'm going to put these over a common denominator. So I'm going to have 28 times x plus 2 over x plus 1, x plus 2, minus 30 times x plus 1 over x plus 1, x plus 2. They're still equal to 1. So what I've done is, this fraction I need to multiply by x plus 2, so I've done that here. And this fraction I need to multiply by x plus 1, so I've done that here. And now they're over a common denominator. So I've got 28 x plus 2 minus 30 x plus 1, and that's all over a common denominator of x plus 1, x plus 2 equals 1. From that point, I can multiply both sides of the equation by x plus 1, x plus 2. That will get rid of it on this side and multiply on this side. So if I multiply this side by x plus 1, x plus 2, that means I get rid of the denominator. And if I multiply this side by x plus 1, x plus 2, I just have x plus 1, x plus 2, because it was multiplied by 1. Now I'm going to multiply this out. So I've got 28x plus 56 minus 30x minus 30, be careful with your signs when you're multiplying out, equals x squared plus 3x plus 2. I'm going to collect like terms on this side. Missed my x out there, sorry. So 28x minus 30x gives me minus 2x. 56 minus 30 gives me plus 26, and that's equal to x squared plus 3x plus 2. I'm going to take everything over to one side by adding 2x and subtracting 26. So if I add 2x and subtract 26, then on this side I'm going to be left with 0. On this side I'm going to have x squared, 3x plus 2x, so plus 5x, 2 minus 26 minus 24. I've now got a quadratic that's equal to 0, so I can try to factorise it. In fact, this does factorise. It factorises into x plus 8, x minus 3, and that is equal to 0, which means that our solution is x equals negative 8 or x equals 3. So that should be enough for you to do questions 9 to 12. I'm now going to do an example for question 13 onwards. So this is similar to the questions for question 13 onwards. It's giving you a ratio of 2 expressions, and it's telling you that the ratio 2x plus 8 to x plus 4 is the same as the ratio 5x plus 1 to 2x plus 3. So what that means is, if I take the ratio 2x plus 8 to x plus 4, and I take the ratio 5x plus 1 to 2x plus 3, those ratios are equivalent. When we have equivalent ratios, it means that both parts of the ratio have been multiplied by the same thing. I'm going to call it n. So 2x plus 8 times something, which I'm calling n, will be 5x plus 1. And if I times x plus 4 by that same something, that same n, it would give me 2x plus 3. So what that means is, if I did 2x plus 3 divided by x plus 4, I would get n, because really this is saying that n times x plus 4 equals 2x plus 3. And the same thing here, this is really saying that n times 2x plus 8 equals 5x plus 1. If I divide this by 2x plus 8, I get that 5x plus 1 over 2x plus 8 is equal to n. If I divide this by x plus 4, I get that 2x plus 3 over x plus 4 is equal to n. So what does that mean? It means these two fractions are equal. If I do this divided by this, I get n. And if I do this divided by this, I get n. So these ones divided by these ones, if I set that equal, those are equal algebraic fractions. You get rid of this bit. You don't need this bit. It was just me showing you what I was doing and how I'm getting to the bit that I'm going to write down now, which is 5x plus 1 over 2x plus 8 equals 2x plus 3 over x plus 4. So this divided by its equivalent part of its equivalent ratio is equal to this divided by its equivalent part of its equivalent ratio. And now I've got an algebraic fraction equation to solve. So this is the algebraic fraction equation we want to solve. And to solve this, I'm going to start by timesing both sides by x plus 4. So I've done the same to both sides, and if I do that, on this side I'll have 5x plus 1 times x plus 4 over 2x plus 8. And on this side I'll have 2x plus 3 times x plus 4 over x plus 4. Well, these will just cancel. I can divide that x plus 4 by that other x plus 4. So I'm left with this. Then, same kind of method, I'm going to times both sides by 2x plus 8. If I times this side by 2x plus 8, it will cancel. So 2x plus 8 times that and that will cancel. So we'll have just 5x plus 1 times x plus 4 equals 2x plus 3 times 2x plus 8. Now I'm going to multiply these out. So on the left hand side, I'm going to have 5x squared plus x plus 20x, so plus 21x plus 4, and that's going to be equal to 4x squared plus 6x plus 16x, so plus 22x, and then plus 24. I'm going to subtract everything from this side, so that I've just got one quadratic on the left hand side. So 5x squared minus 4x squared gives me x squared. 21x minus 22x gives me minus x. 4 minus 24 gives me minus 20. And because I've subtracted everything from this side, I end up with 0. So this is the quadratic we'd got to, x squared minus x minus 20 equals 0. So now we want to see if we can factorise it. And we can. We're going to get x minus 5 into x plus 4, which means that our solution is x equals 5 or x equals -4. So the original question was, given that these two ratios are equal, find the possible values of x. We set up algebraic fractions by dividing the equivalent parts of the equivalent ratios and setting them equal. Once we'd set them equal, we worked through the algebra by multiplying by each side by the denominators, turning it into some quadratics, making that into one quadratic by collecting like terms on the same side of the equation. Then we factorised it and we have found the possible values of x, which is what the question wanted us to do. So that should now be enough for you to do questions 13 onwards on the test as well. If you get stuck on any of the questions on the test, please let me know on Show My Homework and I will record a video for them.